In this video, we are going to learn what radians are, how to draw angles in radians without converting them to degrees first, how to convert between radians and degrees using proportional reasoning, and when to use the conversion formula. Download your free radian circle chart so that you can draw angles in radians and convert between radians and degrees with ease. Link in description below. Many real-world phenomena can be modeled by sine and cosine functions. Think anything that happens in a cycle, like the maximum height of the sun in the sky throughout the year, or the motion of your seat as you go around the Ferris wheel. Not to mention things that go up and down periodically, like a piston in an engine, or waves of any kind, such as sound waves, light waves, water waves. To model these patterns mathematically, we need to measure angles with not degrees, but a new unit called radians. Radians is just another unit of measurement for the amount of rotation around a circle. You're already familiar with the fact that if you rotate once around the circle, it's 360 degrees. 360 is a convenient number to choose because it is easily divisible by many numbers, making it useful for mental calculations. But there's another way to measure angles. When we measure it in radians, we answer the question, what is the angle swept out when we travel a set distance around the outside edge? Well, if we travel around the circle, the length along the outside edge is called the circumference, which is calculated using the formula c equals 2 pi r. In a unit circle, the radius is 1, so the circumference is 2 pi. 2 pi is also the angle. If we travel halfway around the circle, the distance traveled is pi, and the angle is also pi. So pi radians is equal to 180 degrees. Remember this unit conversion. It will help us convert between angles in degrees and radians later on. What is 1 radian then? If you take the length of your radius and lay it on the circumference of your circle, this distance that you travel along its edge is 1 radian. This is also approximately 57.3 degrees. Here's a common misconception. A lot of times, students think that if pi is in it, it's radians. But whether or not pi is in it has nothing to do with whether or not the measure is in radians or degrees. What actually matters is the unit. If you see a degree symbol, it's in degrees. If it has no unit, it's radians. Another thing worth noting is that pi is just a number approximately equal to 3.14. So when you see pi degrees, this means 3.14 degrees, which is a really small angle. But if you see 4 with no unit, this is 4 radians, which is not the same as 4 pi radians. 4 radians means that it's 4 multiples of 57.3 degrees, which is approximately 229 degrees. To get familiar with angles and radians, first we want to learn how to draw them without converting them to degrees every time. Since every half circle or pi is equal to 180 degrees, we can draw angles pretty easily. 2 pi is 2 half circles, 3 pi is 3 half circles. If we cut a half circle in half, each half is pi over 2, which is 90 degrees. If we cut it into 4 equal parts, each section is pi over 4, or 45 degrees. If we split it into 3 equal parts, each section is pi over 3, or 60 degrees. If we cut it into 6 equal parts, each section is pi over 6, or 30 degrees. Here's a mini lesson on how to draw these angles by hand, because a lot of students have trouble with this. To draw pi over 4, we're going to use a square as a guideline. We're going to draw dots at the corners, and then we're going to connect these lines diagonally. To draw pi over 3, instead of drawing a square as a guideline, we're going to draw a tall rectangle. Pi over 3 is bigger than pi over 4, so we need to draw a tall rectangle to show the larger angle. To draw pi over 6, start with the pi over 3 circle, draw 3 lines halfway between the lines that you already drew. Let's do some examples. If I want to draw 3 pi over 2, I'm going to get my picture of pi over 2, and then I want 3 of these pieces. So 1, 2, 3. To do 3 pi over 4, I want my pi over 4 picture, and then I want to count to the 3rd piece. And then here's 3 pi over 4. Negative 7 pi over 6 means that we want to go clockwise around the circle. So here's my picture of pi over 6, and I'm going to count 7 pieces clockwise. I end up here. To do 10 pi over 3, I could take my picture of pi over 3 and count to the 10th line. Another thing I could do is to remember that one circle is 2 pi. If this is a pi over 3 circle, then 6 equal pieces make 2 pi. To get to the 10th piece, I need to count 4 extra lines. I will end up here. How do we draw angles in radians that are not fractional multiples of pi? Let's take our unit circle here, divide it into pi over 2. Remember that pi is a number approximated by 3.14. If we are asked to draw an angle 3, we'll remember that this is 3, not 3 pi. 3 is just slightly less than pi, so I'm going to put a line here. I'm going to convert my half pi's into decimals so it's easier to see where 8.5 radians should land. Since 8.5 is greater than 6.28, it will be one full rotation plus some more. 2.21 is almost halfway in between 1.57 and 3.14, so I will draw my line here. Here's how we can convert from radians into degrees without drawings. If you work with these common fractions of pi, you likely will be very familiar with these conversions. Since we already know that pi over 2 is 90 degrees, 3 pi over 2 must be 3 times 90 degrees. Another way that I could do these is just to replace pi with 180 degrees. Wherever you see pi, you just cross it out and put down 180, and then calculate it. Here are 2 more examples using the same logic. For the following examples, we're going to convert them from degrees to radians. First, we ask ourselves if the angle is a multiple of 30 or 45. In the first example here, I know that 210 can be broken down into 7 times 30. Since we already know 30 degrees is pi over 6, 210 is 7 pi over 6. 315 degrees is 7 times 45. Since 45 degrees is pi over 4, 315 is 7 pi over 4. 240 is 8 times 30 degrees, so it's 8 pi over 6, which simplifies to 4 pi over 3. Alternatively, you can look at 240 as 4 times 60, and since we know that 60 degrees is pi over 3, it's 4 pi over 3. What if our conversions involve degrees that are not multiples of 30 or 45, or if our radian measures are not a nice fraction of pi? In these cases, we would use this formula. You might be wondering why I emphasize learning to think in radians instead of converting every radian measure to degrees before doing your calculations. It's kind of like learning a new language, say French. If you constantly translate French into English to understand it, then translate your thoughts back into French to respond, it slows you down. You're not truly thinking in the language. The same goes for radians. If you keep converting to degrees just to make sense of things, you're adding an extra step that gets in the way of fluency. Thinking in radians directly helps you become faster and more confident with math. And that's what I aim to do with all of my students. I hope this video helped clarify any questions that you had about radians. My name is Clara Tong. I'm the math tutor behind this YouTube channel, Precalculus Help Online. I've helped hundreds of students through trigonometry, and I created this video based on my knowledge of what students struggle with when they learn this topic. Since I repeat myself over and over and over again to my one-on-one students, you can sign up to become one here if you would like. I thought I would create more resources to help more students. If you enjoyed this video, please give it a like and subscribe to my channel for more content. Thank you for watching, and I will see you in the next video.